In this video, we introduce an OPRA-Vis, a visual analytics system designed to assist public relations experts in organization public relationship assessment by leveraging large language models. This system integrates PR expertise directly into the model's thinking process using COT prompting, making the LLM's reasoning for labeling explicit and allowing users to guide and refine the model's assessments. OPRA-Vis consists of three tightly coordinated views. The OPRA Concept Space View provides a high-level overview of the data. The Data Management View is used for inspecting individual instances. The LLM Reasoning and Editing View is used to analyze and modify the LLM's detailed reasoning. The OPRA Concept Space View utilizes an octagonal layout to represent the four key OPRA concepts and their corresponding true or false labels. When users click a concept label, the certainty of concepts is visualized with color. The distribution chart displays the density of COC scores, which assists in identifying data clusters that require further review. The surrounding tag clouds visualize word sentiment. Green indicates positive and red indicates negative sentiment, offering insight into the terms influencing the LLM's assessment. Users can use the lasso selection tool to focus on an area of interest and cluster data points. The selected points are then filtered and displayed in the Data Management View for detailed analysis. In the Data Management View, data is filtered according to the user's selected concept or area, and users can further filter the data by COC value using the slider. The table displays the COC score, the LLM-generated label, and the expert-provided ground truth label, which allows for the immediate identification of discrepancies. When a user selects a sentence for analysis from the table, the corresponding words from that sentence are highlighted in the tag cloud, and the LLM's detailed reasoning process is loaded into the LLM Reasoning and Editing View. The LLM Reasoning and Editing View allows users to examine the LLM's COT reasoning process. The LLM first extracts clues from the input, generates a logical reasoning process based on those clues, and then determines the final label. The inter-sentence attention visualization indicates which parts of the input prompt influence the LLM's generation, providing evidence for the model's reasoning for labeling. If the LLM's reasoning is flawed, users can open the prompt editor to correct the clues or provide improved few-shot examples to guide the model. Running the assessment with the edited prompt triggers a re-evaluation, and the system provides an updated result. In this way, OPRA-Vis enables users to interactively analyze and refine the LLM's reasoning for PR analysis. In this scenario, we will demonstrate how to address LLM misclassifications caused by linguistic phenomena such as negation. The dataset consists of 198 Amazon product reviews. Investigation through OPRA-Vis reveals that the distribution chart in the bottom left of the OPRA Concept Space View partitions the data into three distinct groups. Upon exploring the leftmost group by filtering for data points with a COC score between 0 and 0.3, we found that this cluster contained several instances of linguistic negation. We used the lasso selection tool to cluster and filter these ambiguous data points for review. The Data Management View reveals a mislabeled instance where the LLM's label of false conflicts with the expert's label of true. We now examine the LLM's reasoning. The view shows the LLM misclassified the phrase, "water doesn't bother it too much," as a false clue, highlighting its difficulty in handling negation. The attention visualization confirms this incorrect clue was the primary influence on the flawed reasoning. To correct this, the user edits the prompt, reclassifying the phrase as a true clue. After running the assessment again, the LLM generates a new correct reasoning process and updates its final label to true. This correction is then propagated to the entire dataset. This is the end of the video. Thank you for watching.